When we look at our next example, example 4, part 1, I guess, we're going to consider factoring. So when we first look at this function, okay, two things to think about. We want to evaluate this limit as x approaches -2. Well, here we can't use direct substitution because x equals -2 would make this function undefined. Okay, so we can't do direct substitution. And we also can't use the limit of a quotient because the limit of the denominator would equal 0. Okay, sorry, a little bit of abbreviation there. So what about factoring? Okay, x squared minus 4 in the numerator is a difference of squares. So let's first take a look at this as x plus 2, x minus 2 on top over x plus 2 on the bottom. So then if we canceled out those x plus 2's, that eliminates that division by 0 issue. So now we just have the limit as x approaches -2 of x minus 2 over 1, I guess, if you wanted to look at it that way. So now we can substitute in -2, and then we end up with -2 minus 2 over 1, which gives us -4. So this limit as x approaches -2 is equal to -4. In the next example, we're going to look at doing some simplifying to see if that can help us, because we're supposed to evaluate this limit as x approaches 0. Well, obviously you can see that we've got an x in the denominator, so if we were to do direct substitution, that's not going to work because we're going to end up dividing by 0. But we do have this 4 plus x quantity squared. So keep in mind, the 4 plus x quantity squared is really 4 plus x times another 4 plus x. And then we have minus 16. So if we were to FOIL that out, we would end up with 16 plus 4x and 4x, which would give us an 8x, plus x squared, and then minus 16. And again, that's all over x. Well, right away, we can cross out the 16 and the -16. So then, if we put our terms in descending order here, we're left with x squared plus 8x over x. And then we could factor an x out of the numerator. And if we do that, then we end up with x times x plus 8 over x. And now we can cross out that factor of x that is the problem. And so now we are able to do the limit as x approaches 0 of x plus 8, which gives us 0 plus 8, which gives us 8 for our answer. The last thing that we're going to learn about today for our bag of tricks as far as evaluating limits is rationalizing a numerator or a denominator. In this case, as you can see, the radical that we're dealing with is upstairs. So here we are going to look at rationalizing the numerator. Whenever you see a square root, that's typically where we're going to need to go. When you look at the fact that we're trying to evaluate this limit as t approaches 0, right away we've got that problem of we can't use the limit of a quotient because if we plugged 0 in, our denominator would be 0. And same issue with we can't do direct substitution for the same reason because we'd be dividing by 0. So let's take a look at trying to rationalize our numerator. And yes, this is going to get a little bit messy. Okay? So let's start with our original function here. We've got t squared plus 25 minus a 5 after the radical over t squared. So if we want to rationalize our numerator, basically we're looking to multiply by the complex conjugate of the numerator. So the numerator is the square root of t squared plus 25 minus 5. Therefore, the complex conjugate of that would be the square root of t squared plus 25 plus 5. So just like always, whenever we rationalize, we have to multiply the top and the bottom. We're just not usually rationalizing our numerators. But this is one time where, when evaluating limits, being able to rationalize a numerator comes in handy. So now upstairs, when we multiply these two binomials together, basically remember we're foiling here. When we multiply, and remember we don't have to worry about inners and outers when we multiply complex conjugates because those cancel out. So we're just going to do first times first and last times last. Well, when we multiply the square root of t squared plus 25 times the square root of t squared plus 25, we just end up with t squared plus 25. And then when we multiply our lasts, negative 5 times 5, we end up with negative 25. And then in the denominator, when we multiply, we just end up with that. I'm just going to put the t squared next to the binomial, the square root of t squared plus 25 plus 5, like that. So now upstairs, when I simplify this, the positive 25 and the negative 25 are going to cancel out. So that leaves me with t squared in my numerator over t squared times the square root of t squared plus 25 plus 5. So now my t squareds are going to cancel out. So I end up with 1 over the square root of t squared plus 25 plus 5. So now I'm ready to plug in 0 for my t value, which gives me 1 over the square root of 0 squared plus 25 plus 5. Well, 0 squared is 0, 0 plus 25 is 25, and the square root of 25 is 5. So this ends up being 1 over 5 plus 5, which means that my limit is equal to 1/10.